A good day. Now let us do this next example. It's another limit that we need to evaluate by numerical approach. Here, this is the function. We want to take the limit as x approaches 4 of this function g of x. So once again now, we are approaching 4. Let's look for some values. 3 values approaching 4 from the left and 3 values approaching 4 from the right. So here, we're going to start with, for example, 3.9, then 3.99, then 3.999. We're approaching, getting closer and closer to 4 from the left, and the values are smaller than 4. And then from the right, we can start with, for example, 4.1, and then 4.01, and then 4.001. You can see that from 4.1, we are getting closer and closer and closer to 4. So we're approaching 4 from the right. Here we're approaching 4 from the left. So our job here really is to evaluate this function here, okay, at each of these x values. So we need to do f of 3.9, we need to do f of 3.99, we need to do f of 3.999. So what is f of 3.9? Well, this is going to be 2, open bracket, 3.9 to the power 3 minus 5, 3.9 to the power 2 minus 3 times 3.9 plus 2, over 2 times 3.9 to the power 3 minus 3 times 3.9 to the power 2 plus 3.9 minus 1. Then you go to your calculator, evaluate this properly. You should be able to obtain, 0.433 in 3 significant figures, 1, 2, 3 significant figures. Then you go ahead and do the next one, 3.99. So this one is going to be 2 times, so where there's an x, you replace that with 3.99. Remember, this one obtained f of x to be 0.433. So 3.99, please do the same. So you replace every x by 3.99, so that is cubed here, minus 5, 3.99 squared minus 3, open brackets, 3.99 plus 2 over 2, 3.99 cubed minus 3, open brackets, 3.99 squared plus 3.99 minus 1. You see, every x here I've replaced by 3.99. Now punch that in your calculator correctly. You should be able to get 0.455. So here you get 0.455. Alright, so go ahead and do the same thing for f of 3.999. Due to time, I won't be able to do this one, but you simply replace every x here at 3.999, just like we did with the others here. So if you do that correctly, right, so you should be able to get 0.455. 0.455. Then go ahead and do the next one. For this one, f of 4.1. Okay, what it means is, for every x in this function, replace it ka 4.1 and then punch in your calculator, you will get 0.481. Then go ahead and do f of 4.01. What does that mean? For every x here, replace it ka 4.01, punch in your calculator, you will get the correct answer, which in this case should be 0.460. And then finally do f of 4.00, hope it's clear, 001, like this. Okay, replace every x here ka 4.001 and get the correct answer, 0.458. Okay, so actually I made a mistake here. This is 0.458 if you punch correctly. So here we have 0.481, here we have 0.460, and here we have 0.458. That's all you have to do here. And now you can say, as the values of x approach 4, the values of f of x approach 0.458. 0.458. That is our limit. Thank you.